Hey, seventh graders, it's Mrs. Wyland. I'm sorry I can't be there this afternoon, but our dog is really sick, as a lot of you know, and we've decided that we'll be putting her down this afternoon. So that's why I'm not here. I wanted to let you know that that's the reason why I'm gone, and I will be seeing you next time. So in the meantime, here's what you'll be doing today with the sub. So if you could start by taking out your science packet and opening up to the page that looks like this one. I don't have a packet in front of me at home, so I don't know the page number. I think it might be page 24, something like that. If you can head to the page that looks like this one and spend some time filling this out as I talk about what's up on the screen. So the theory of plate motion is the exact same thing as the theory of plate tectonics. So two different names for the same big idea. This theory, and again, remember in science, a theory is not a guess. It's a big idea backed up by a lot of evidence. And this theory of plate motion explains how the Earth's crust has formed over time, and then how it moves across the Earth's surface, and then how it becomes subducted or disappears and gets recycled back into the Earth. So that's what the theory of plate tectonics is all about. Last class we learned that there are three types of boundaries. So I've got transform boundary here, divergent boundary, and convergent. So you're going to want to write those in. The exact bubble that you put them in does not matter. Please also include a quick description of how the plates are moving. So remember, transform boundaries, the plates slip past each other and the edges of the plates are rubbing. With a divergent boundary, the plates move apart, and convergent boundaries, the plates move together. It would also be a really good idea to draw in some arrows as visuals, as I have here, and you should also include an example of each type of boundary. The examples that I have here are examples that you will be seeing on our test next week, so you should know these. So the San Andreas Fault, as I talked about in class, is a transform boundary located in California, runs right through the city of San Francisco, and the edges of two tectonic plates are rubbing past each other there. That's why they get so many earthquakes. A divergent boundary, again, is where the plates move apart. And a really good example would be the mid-ocean ridge that we've been learning about, that's at the bottom of the ocean, that has the seafloor spread apart. And then an example of a convergent boundary where plates come together, a good one to keep in mind is the Himalayas, where Mount Everest is located. When India smashed into the Eurasian plate, it created the Himalayas. So what can we conclude basically by learning all of this information about the different types of plates? Well, we can learn that plates move really slow. We know that for sure. We can't see the plates moving, but over millions of years, the plates can actually move great distances. And we know that our tectonic plates were once one as a supercontinent named Pangaea and have been moving apart ever since. So this is what I'd like you to have on that packet page, whichever one it is. If you need to pause the video to allow students to get caught up, now would be a great time to do that. Otherwise, I'm going to keep going with the lesson. So at this point, I would like you now to go back in your packet to pages, I believe it's 19 and 20. Let me show you what it looks like. So this is the page I'm hoping you can find. And down below, it's got this data table, okay? So here's the idea of this activity. So for this next activity, the big idea is, how did scientists figure out where the edges of the tectonic plates actually are located? Because you really can't walk across the Earth's surface and see the edges of all of our plates. You can see some at the Earth's surface where it looks like kind of a ridge between two places, but in most areas you really can't see the edges of the boundaries. So how did scientists figure it out? So that's what we're going to be looking at today. I am going to pause really quickly and just say a quick little message to my kiddos that are pacing faster. I know some of you have already done this activity, and so you're wondering, what do I do next? If you have completed pages 19 through, I think it's page 23 in your packet, here's what it looks like. So you've completed all of these questions, okay? Then you can continue in your packet and you'll see 2 more pages about volcano and mountain formation. So you're going to want to do those, and there are 2 Google Slides available for you on Schoology. I'm hoping that students like Lucia and Celeste and Jack in 5-6A and Tanvi and Chung and, hold on, it'll come to me. Oh, and Sadia, that are pacing quicker in 7-8A could help students that might have some questions regarding this, this lab with the plotting of the volcanoes and earthquakes that I'm about to explain. And also, those of you that are pacing quicker, if you get stuck or you're really not sure what to do, then feel free to certainly look on Schoology in the what's it called, assessment folder, and you'll see stuff you can start studying and getting ready for actually taking your test eventually. So that would be something you could do if you're stuck without me being there. For the rest of us, here's how this activity goes. So you're going to need to find that really big bathymetric map, that huge world map that I gave you earlier in the unit. And the one that I'm talking about looks like this. So dig around in your folder, see if you can find it. If you can't find it, I do have extras up on the front table, but they're just the black and white versions, but they'll be just fine. And it doesn't matter if you don't have these letters on it anymore. That's just fine if you have to grab a brand new map. Otherwise, if you have your map, please use it. And now what we're going to do is, if we go back to our packet, we are asked to examine our map and basically look for certain features that our map has to get started, just to become familiar with it. So first of all, it talks about looking for mid-ocean ridges that I have highlighted here. And then we're going to try to find some trenches that are labeled and some mountain ranges, which another word for mountain range that you're going to hear is the word rise. So if I go down to my data table, it says mid-ocean ridge, and I need to find an example from my map. So with my map here, you're going to see a lot of really small little words that are in the ocean, okay? This one might be hard to see on the big screen, but it's called the Pacific and Arctic Ridge. Over here in the Atlantic is the Mid-Atlantic Ridge, okay? Remember, ridges are places where the magma oozes out of the ground, solidifies, and then pushes the seafloor apart. So what I need you to do is, in your packet right here, you're just going to write an example of a ridge. So I could write the Mid-Atlantic Ridge if I wanted to. You are welcome to do the same. Because at a ridge the plate boundaries move apart, we know that that is a divergent boundary. And then over here you're going to be asked to draw in some arrows that move in opposite directions, but I'm not going to be able to do that very quickly for you here on the screencast today, but I think you guys can manage just fine. You'll notice, again, if I go back to this document, that there are ridges all over the place. So you can basically come up with, any of them that you want to write down in your data table. That's okay. Then here we're asked to find a rise. So rises are just another term for mountain. So if I go back to my map, the rises are a little trickier to find. And of course, this is very, very small. But if I go to here, I'm going to go to this. If I go over here, this is just a close-up view of my map. And near Australia, there is a rise right here. I can't even tell what it's called from here, and I don't have a map at home for me to look at closely. Not sure what it says. but there's a rise. I think it's called Lord something Rise. So hopefully you can tell on your map. So Lord, I'm not sure what it is, Rise, but it's just an underwater mountain, basically. Forms in a different way than our Mid-Atlantic Ridge, which is also a mountain. Here, the plates are coming together. It just is happening under the water, so we call it a rise, and you can draw two arrows coming together. Then down here, trenches. You'll notice there are trenches all over the map. There's a ton of them around the Pacific Ocean. Again, the font is really small for me to see here, but this one where my cursor is called the Aleutian Trench. That's a good trench that we could write down. The Mariana Trench is over here near Australia as well. So pick any name of a trench that you would like and write it down. Okay. I'm going to write down the Mariana Trench, and trenches have two tectonic plates coming together. One just subducts under the other. Because they come together, they are an example of a convergent boundary. And when you draw your arrows, please just have one arrow look like it's kind of going underneath the other. All right, so now that we know what kind of features are on our map, we're going to continue on to the next page. So now it says that at the top, Earth has 7 to 10 large pieces and many small plates, like tectonic plates. But to keep things simple, we're going to only focus on the 7 large tectonic plates. It says, keep in mind that our mid-ocean ridges, the trenches, and the mountain ranges are geologic features that form at the boundaries of these plates, where the plates are meeting up. So step 3 says, with your pencil, and I highly encourage you to use a pencil because in previous years, lots of mistakes will happen at this point. You're going to take your pencil and outline locations where there's a mid-ocean ridge, a deep ocean trench, and mountain ranges. So let me show you a quick example of that right here. Okay, so this is just one small area on my map, but anywhere that I can see the words ridge or rise or trench, I'm going to take my pencil and go over those words on my map. So you might want to pause at this point and take some time to do as many of those places as you can see on your map. Trace over, again, the ridges, trenches, and rises. All right, so now what we're going to do is we're on to part 3. So for part 3, we will be plotting a bunch of earthquakes. And remember, we're doing this to try to answer the big question of how did scientists figure out where the edges of our tectonic plates are actually located, because we really can't see the boundaries on many parts of our Earth's surface. To do this next step, I'm going to have to help guide you on how to set up your big map to be successful. So to do that, I'm going to go to here. So on your big map, and you might have to pause quite a few times for students to catch up, but first on your map, you're going to notice that at the top, you've got a bunch of degrees, and you'll see little letters, east and west, or E and W for east and west, and then we've got north and south. Okay, what usually works best for students in previous years is if they draw themselves some reminders. So if you can head over to the right side of your map and find Europe, right where my cursor is, and head up to 0 degrees longitude. At that place, draw an up and down line, just like my cursor is showing you. And then everything to the right is east. Now again, our world is round, and so east continues from the left side of the map all the way till we hit 180 degrees longitude. So when you hit that point, you're going to make another line and make sure you label it east. Everything in between is west, is what my cursor has here. I know that there's the little E's and the little W's, but having kids see it at a much bigger like this is usually very helpful. And then over on the right-hand side, I would certainly at the equator make a little mark where 0 is located and everything above is north and everything below is south.